In problem 8, it says because of variation in the manufacturing process, baseball bats are produced by a particular machine do not have identical lengths, which is supposed to be 36 inches. The population standard deviation is 1.25. If the average length of the first 50 bats made from a machine is 35.5, shall we stop and calibrate the machine? Use alpha 0.10 for your level of significance. So here you can see we have the null hypothesis set up, which is mu equal to 36. There, and the alternate hypothesis is mu not equal to 36. Type of test. This is going to be a two-tailed test because it's not equal. And alpha again was 0.10, n equals 50, x bar is 35.5, and sigma is 1.25. So again, this is a two-tailed test. Okay. The z-statistic, that's the first thing we have to calculate. So remember that the z-statistic, put over here, is z equals, you're going to take the difference in the means. So we're going to do x bar minus, well, I'll just put the numbers in. It's going to be x bar, which is 35.5, minus 36, which is mu. We'll take that whole thing and divide it by, I'm going to move this over a little bit. Divide that by sigma, which is 1.25, divided by the square root of 30, was the first 50 bats, so square root of 50. Okay, make that a little smaller. All right, here we go. So if I put in my calculator, I like to do 1.25 divided by the square root of 50. Okay. And then I'm going to, well, I'll do 35.5 minus 36. Minus 36 and divide that by the second answer. Oh, it's not a minus. All right, so I'm going to do, well, 35.5 minus 36 is negative 0.5. I'm going to divide that by, we'll round this to 4 decimals, 0.1768. All right. That gives me a t-statistic of negative 2.83. We'll round that to 2 decimals. So what's my p-value? Well, it's a two-tailed test. So it's going to be twice the area that the probability is, I would say, less than negative 2.83. Okay, so just looking at the picture here, okay, we're doing a two-tailed test, so we have, excuse me, so this was a negative 2.83. This one would be 2.83. Okay. So the p-value is the area in the tails. So there's two of them, and they're symmetric, so they're the same. So I could calculate either one of these and double it, right? So if I come over to here, I do second vars, and I'll do normal CDF, and I can use negative 100 for lower bound, negative, oh yeah, I need to put this negative, okay, negative 100 for my lower bound, and negative 2.83 for my upper bound, and it's standardized, so 0 and 1 is the mean and standard deviation. That gives me 0.0023. That's one tail, so I got to multiply that by 2. So therefore, the total area, my p-value, is equal to 0.04, 0.0047, we'll call it. Okay, so let's go back over. So p-value is equal to 0.0047. Make that a little bigger. Okay. So I said 2 decimals, but you're going to want to do 2 significant digits here. Let's just get rid of that. Okay. So what is the test results? Well, we need to compare that to alpha. So remember, if p-value is smaller, less than or equal to alpha, then we reject the null hypothesis. So here, we're going to be comparing the p-value, which is 0.0047, to alpha, which is 0.10. And we do see that this is less than or equal. So we're going to reject the null hypothesis. Okay. So should they recalibrate the machine? Yes. Because we're rejecting the fact that it's equal to 36, and we want it to be equal to 36, so we're saying it's not equal. We're supporting the alternate hypothesis.